Hello and welcome to Maths with Jacob. This lesson will focus on cross-section. This is another extension topic. A cross-section is created when you saw or cut through a 3D object. 3D means three-dimensional. The cross-section is the flat face and it is exposed after you make the cut or complete the sawing action. Let's look at the examples. When you slice through an orange, the exposed part is the cross-section, and that's very easy to see, and I'm sure you've seen that happen on many occasions. When a log is cut with a saw, the exposed part is the cross-section. Very easy to see and quite easy to understand. Now, these parts are a little bit more challenging. The cross-section of a prism. When we perform a cross-section which is parallel to the base of the prism, the shape of the cross-section is exactly the same as the base. So here is a prism. There's the top, which is a square, for example. There's the bottom, which is a square, and the prism goes up like that. We've seen many examples of a prism in previous videos. Now what we have, if we slice that across there, then and this plane or the saw or whatever we use to do the slicing, if that's parallel to the base, then the cross section is exactly the same shape as the base and the top. The cross section of a cylinder. When we perform a cross section which is parallel to the circular base of a cylinder, the shape of the cross section is exactly the same as the circular base. So again, if you slice that cylinder through there and this yellow plane is parallel to the base, then that circle is exactly the same shape and size as the base. The cross section of a cone. When we perform a cross-section which is parallel to the circular base of a cone, the shape of the cross-section is circular. However, the size of the cross-section is smaller than the base. So pretend that's a cone, like it could be an ice cream cone upside down or one of those cones you use on the roads. If you slice it across there, that is definitely a circle, but it's smaller than the base, and that's obvious. Because as you go up the cone, it gets smaller and smaller. Cross sections not parallel to the base. When we perform a cross section which is not parallel to the base of a prism, the shape of the cross section is not the same shape as the base. In the case of a square prism, the shape of the cross section is a rectangle. So when you slice this thing at an angle, you can see the cross section there, it comes out to be a rectangle. And you can actually practice that on some shapes. Quite easy to do. If you get some simple shapes, you can buy wood from the craft shop which is really soft, and it's in the shape of many types. So you can have a lot of prisms when you buy the wood, many types of prisms, very easy to cut, and you will see the different shapes of the cross sections. When we perform a cross section which is not parallel to the circular base of a cylinder, as shown above, the shape of the cross section is not a circle. However, the shape of the cross section is a very special oval. It is called an ellipse. So you can see the cut here is not parallel to the base, and that's why you get this oval, and that's called an ellipse. Now again, you can buy these shapes here from a craft shop, and the wood is really soft and it's very easy to cut, and then you can see the shape of the cross section. When we perform a cross section which is not parallel to the circular base of a cone, as shown above, the shape of the cross section is not a circle. However, the shape of the cross section is an oval. Okay, so see the cut here? The cut is not parallel to the base, but we get an oval. It's actually similar similar shape to this thing here, but it's called an oval. This is an ellipse, but that does not turn out to be an ellipse, so we'll just call it an oval. So this video has been a little bit challenging for you, but sometimes that's a bit interesting. But you can easily understand these a lot better if you buy all these shapes from the craft shop with that really soft wood, and when you saw them, you can see exactly what's happening.